Okay, I'm going to make a little video to help you with your homework here. Now, in section 1.1, we learned about exponent rules and shortcuts when we're multiplying and dividing exponents to help us do these problems faster. Okay, the first major exponent rule says that if I multiply two powers with the same base, okay, so this is a power here, this entire thing right here, this a to the n is a power. Let me get some actual color here. This is a power. The exponent is m, the base is a. Okay, so when we're multiplying two powers and they have the same base, what we can do is just add the exponents. Okay, these both have a base of a. The exponents are m and n. And if I multiply these together, I can just add the exponents. Okay, now let's do some real examples. So if I have 3, I don't want a pen. No, I do want a pen, not a pencil. Okay, so if I have 3 to the third power and I multiply that times 3 to the seventh power, well, these are powers with the same base, so I can just add the exponents and keep the same base. So this, my answer will be 3 to the 3 plus 7 is 10th power, 3 to the 10th power. Let's do another one. This works for variables as well. So if I have x to the second power times x to the fifth power, my answer is going to be, I'm going to keep the same base and add my exponents. X to the 2 plus 5 is 7th power. Okay, some of the trickier examples are like this. If I have a to the 2x power. Now here the exponent has a variable in it. Okay, you're going to see that at some point. So if I have a to the 2x and I multiply that times a to the 5x, well, I have powers with the same bases. That's a. I'm going to add my exponents. 2x plus 5x is 7x. So my final answer would be a to the 7x. Okay. Let's take a look at some more exponent rules. Okay, the next exponent rule is when we're dividing powers with the same base. All right, this says if I'm dividing powers with the same base, I'm going to take the two exponents, m and n, and subtract them. Okay, let's do some real examples here. So if I have 5 to the 4th power, and I'm dividing this by 5 to the 2nd power, okay, powers with the same base, I'm dividing, so that means I'm going to subtract the exponents to find my answer. Same base, 5 to the 4 minus 2 power. Okay, now the order does matter here. So it's just like subtraction. You always take the dividends exponent and subtract the divisor's exponent, but really just think of it as subtraction, okay? This one minus this one. All right, let's do another one. So we've got x. But this also works for fractions, because fractions, writing division as a fraction is the thing you can do. So if I have x to the 7th power divided by x to the 3rd power, so again, dividing powers with the same base, I can just subtract the exponents. X to the 7 minus 3, which is x to the 4th power. Okay, let's move on to the next law. Raising a power to a power. Okay, so this says that if you have a power and you raise it to a power, you can just find the easy answer by multiplying these two exponents. That's what this gobbledygook here says. Okay, so if I have 3 to the 6th power and I raise that to the 2nd power, okay, so 3 to the 6th times 3 to the 6th, my answer is going to be 3, same base, to the 6 times 2, which is 12th power. Okay, same thing for variables. X to the 3rd, if I raise that to the 7th power, if I wrote that out, it would be x to the 3rd times x to the 3rd, 1, 2, 3, 4, 7 times. Now, I don't want to do that. That's a pain. Okay, so that's why we're using these shortcuts. So x to the 3 times 7 is x to the 21st power. Okay. Oops, I messed up. see if I can fix this quickly. Salvage the video. I don't want to do this again. Okay. Next one. All right, so when we take a product, when we have a product, so A times B, and we raise that to a power, what we're going to do is we're going to raise each one of these factors, so the A and B, to that power. Let's do an example. So if I have 3x, and I raise that to the fourth power, I'm going to have to raise 3 to the fourth power and x to the fourth power. So it's going to look like this. 3 to the fourth times x to the fourth. They're still being multiplied, but I had to raise both of them to the fourth power. So this would be 3 to the fourth is 81, and x to the fourth is just x to the fourth. Okay, let's see if I had 3 times 6. So this is a product. 3 times 6 is a product. And I raise this to the third power. Okay, so let's say I have to raise 3 to the third power, which would be 3 to the third, and 6 to the third power, and multiply those together. So this would be 3 to the third, which is 27. 6 to the third is 216. And I don't really want to figure out what this is. Oh, okay, so 54, 432. 5832, I think. Why can't I draw that? Oh, because I have a layer. So that'd be like 5832. But whatever. You'd probably plug that into a calculator. Let's move on. Final exponent rule. Okay? So when you have a fraction and you raise the fraction to a power. All right, now this says that we're going to raise the numerator and the denominator to that power and leave it as a fraction. Not too difficult. Okay, so let's see. If I have 2/5 and I want to raise this to the third power, and you're going to see this quite a bit actually. The easy way of doing that is raising the numerator to the third power, so 2 to the third, over denominator to the third power, 5 to the third, which is going to give you 8 over 125. Okay. It works for variables as well. So if I have x over y, and I raise this to the fourth power, well, guess what? I'm going to have x to the fourth over y to the fourth. Now, I hope you're not asking why doesn't he subtract the exponents here, because these don't have the same base. Okay, this is x to the fourth and y to the fourth. They don't cancel out. Okay, I hope that helps you on your homework. If not, bring your questions to me, please.